In this section, we begin with an informal description of the phrase divided proportionally. Suppose that 3 children have been provided with a joint savings account by their parents. Equal monthly deposits have been made to the account for each child since birth. If the ages of the children are 2, 4, and 6, assume exactness of age for simplicity, and the total in the account is $7,200, then the amount each child should receive can be found by solving the equation. 2x plus 4x plus 6x equals 7,200. 12x equals 7,200, x equals 600. Solving the equation leads to the solution 1,200 for the 2-year-old, 2,400 for the 4-year-old, and 3,600 for the 6-year-old. We say that the amount has been divided proportionally. Expressed as a proportion divided by 2 equals 2,400 divided by 4 equals 3,600 divided by 6. In figure 5.44, segment AC and segment DF are divided proportionally at points B and E if length AB divided by length DE equals length BC divided by length EF, or length AB divided by length BC equals length DE divided by length EF. Of course, a pair of segments may be divided proportionally by several points, as shown in figure 5.45. In this case, segment RW and segment HM are divided proportionally when RS divided by HJ equals ST divided by JK equals TV divided by KL equals VW divided by LM. Notice that 6 divided by 4 equals 12 divided by 8 equals 15 divided by 10 equals 9 divided by 6. In figure 5.46, points D and E divide segment AB and segment AC proportionally. If length AD equals 4, length DB equals 7, and length EC equals 6, find AE. Solution: AD divided by AE equals DB divided by EC. So 4 divided by x equals 7 divided by 6, where x equals length AE. Then 7x equals 24 by cross multiplying. So x equals 24 divided by 7, which equals 3 3/7. Length AE equals 3 3/7. If A divided by B equals C divided by D, then A plus C divided by B plus D equals A over B equals C over D. In words, we may restate this property as follows. The fraction whose numerator and denominator are determined, respectively, by adding numerators and denominators of equal fractions is equal to each of those equal fractions. Here is a numerical example of this claim. If 2 divided by 3 equals 4 divided by 6, then 2 plus 4 divided by 3 plus 6 equals 2 divided by 3, which equals 4 divided by 6. Two properties that were introduced are now recalled. If A over B equals C over D, then A plus or minus B divided by B equals C plus or minus D divided by D. Theorem 5.6.1. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides these sides proportionally. Corollary 5.6.2. When 3 or more parallel lines are cut by a pair of transversals, the transversals are divided proportionally by the parallel lines. Theorem 5.6.3, the angle bisector theorem. If a ray bisects one angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the two sides that form the bisected angle. The proof statement of the preceding theorem indicates that one form of the proportion described is given by comparing lengths as shown. Segment at left divided by side at left equals segment at right divided by side at right. Equivalently, the proportion could compare lengths like this. Segment at left divided by segment at right equal to side at left divided by side at right. Other forms of the proportion are also possible. Theorem 5.6.4, Sheva's theorem. Let point D be any point in the interior of triangle ABC, and let segment BE, segment AF, and segment CG be the line segments determined by D and vertices of triangle ABC. Then, the product of the ratios of the lengths of the segments of each of the three sides, taken in order from a given vertex of the triangle, equals 1. That is, length AG divided by length GB times length BF divided by length FC times length CE divided by length EA equals 1. For figure 5.53, Shave's theorem can be stated in many equivalent forms. AE divided by EC times CF divided by FB times BG divided by GA equals 1. CF divided by FB times BG divided by GA times AE divided by EC equals 1, etc. In each case, we select a vertex and form ratios of the lengths of segments of sides in a set order.